Welcome to Correlations and Other Statistical Inferences, presented to you by Todd Levenenko, solution provider for TWL ICT Solutions. In this video, we're going to look at part 1 of randomness and how it relates to the understanding of how R works as a correlation between data. In this video, we will be using a random number set generated by a simple application that I created called the Python Random Number Generator. It writes to a file called random.csv, and it runs 25 times from a range from 0 to 100 for x, and a random range of -50 to +50. Once it's done, it closes the file. Okay, let's begin with the randomness. Now, as you can see, I'm using RStudio version 3.4.4, someone to lean on. To begin with, what we'll need to do is load some libraries. And as you can see, I'm running a console here. And what I will do is I will load some of the libraries. And the libraries we need to load are Library Reader, ggplot2, and mgcv. For more information on those, click on Help and type in, for example, mgcv. In the far right here, and you will see the search results for mgcv. And this will give you all the other areas. For example, ggplot2 will give you an example of a help on how to create elegant data visualizations using the grammar of graphics. And from the grammar of graphics, hence grammar of graphics plot 2, you could learn a lot about how we'll be using these. So, to begin with, I'm going to load these libraries. If you don't have these packages loaded, simply click on Packages, type in, for example, Reader, and you'll see that it's here, which is Read Rectangular Text Data. I could click on here, or I could just simply load them, and I will do that from this point. So there you go. I've loaded them. And you'll see some information about an overview of the package. Here you could say type help mgcv-package. For example, help mgcv-package, and you will see that the help for that particular package shows up, which is Mixed GAM Computation Vehicle, and it's deals with smoothing estimations and stuff like that there. So that's that. So now what I want to do is I want to load the random file located in my PyCharm projects, and it's been loaded. I could view the file simply by doing this, view random. hints. As you can see, random has been assigned this value. So if I click on that, here it is. Here are my random values, x and y. So x goes from 0 to 100, and when it's going from 0 to 100, y is being randomly generated as shown in the previous slide. I will now assign x and y to random $x and random $y. Don't have to, although it does make sense if you're writing programs to have variables that you can depend on, and therefore you don't have to do anything like, for example, when I plot x and y, I don't have to, I could say plot random $x, random $y, but in this case just simply typing plot x comma y as x and y have been assigned the values in random. And this is what I have on here in the plots. If I zoom in, this is what I have. I have a random file, random data along the x-axis 0 to 100, on the y-axis minus 50 to plus 50. And as mentioned, you saw that in the previous slide. For example, if I close this, random 11. So in value 8 for x, I have a random value of 11 for y. If I do a summary of random, you will see, as I mentioned, minimum is minus 50, maximum is 49, close to 50. The x is 0 to 100, and we get the first quartile and median, mean, and max. As mentioned in the correlation test, what do we expect to see? Well, we expect to see a value of the correlation close to 0. In this case, 0.00745. This would indicate to us that, based on the sample estimates, there is no correlation. Correlation, ideally, is 1, meaning it's a perfect fit, and 0, meaning it's totally random. Here, we could basically say it's totally random. I'll just show you a bit about data frames. Data frames gives us the ability, in this case, my data frame is assigned data.frame x comma y. This allows me to model, for example, a relationship between x and y. LM is linear. So it's a linear model relating the function of x, which is y, to x in the data, my data frame. This allows me to create a summary of the model as so. And the summary of the model suggests, of course, if we see the adjusted r squared, it's basically 0. Multiple r squared is basically 0. So we don't see any relationship per se. If I plot the model, we get a number of things. we get the value from the intercept and the function of x. You could see it's 0 or close to it, suggesting actually this is a very random model because the top and the bottom seem to coalesce to 0 on the y-axis. So the residue is 0 and the fitted value is Lm, which is the linear mode of y in relationship to x. Again, this information is standardized residuals against the theoretical quantities. We don't see much of a relationship. We're zeroing in, suggesting a very random plot. Again, the square root of standardized residuals against the fitted values is a scale location, which again shows the randomness of the plot. And of course, we will get more into what is Cook's distance, which relates to outliners. Here we don't see any outliners because it's totally randomized. And that's it when it comes to randomized data. The takeaway here, the correlation is 0, which indicates that the data is random. Hence, no real model fits the data that we are observing. Thank you for watching. In the next, we will look at linear relationships and how they will fit in the model.